All of the cameras on board James Webb detect infrared light, which is invisible to the human eye. It can detect this super-stretched infrared light and see beyond that limit. But in order to detect the faint signals of infrared light, the sensors on MIRI have to be extremely sensitive. Increasing the sensitivity, however, introduces a lot of noise. Since Webb is detecting infrared light, the problem gets even worse. Every object in our universe emits heat energy, some of which is in the form of light. Most objects aren't quite hot enough to emit visible light, but they do emit a lot of infrared light. The hotter the object, the more infrared light it will emit, which is essentially how thermal imaging cameras work. Because of this, James Webb itself would emit so much infrared light that its sensors would be completely drowned out. And so, in order to limit the amount of infrared light produced by the telescope, its cameras need to be kept at a temperature of -234 degrees. That is extremely cool. But since MIRI is much more sensitive than the other cameras, it faces an even bigger problem: dark current. This is where the atoms inside the sensor itself vibrate and mistakenly register a photon of light, creating more noise. Since temperature is just a measure of how fast an atom vibrates, lowering the temperature will lower the vibration and therefore reduce the amount of dark current. And so they have to be cooled all the way down to -267 degrees, just 6 degrees above absolute zero. At this temperature, the atoms in the sensor are almost completely still, drastically reducing the noise and allowing the faint infrared signals to shine through.